Yeah.
Okay. So you had a
So
question?
yeah. So Miles was talking about prepend and include. So all this time, the chapter started with include, and when you use include and not prepend, I imagine you're going to switch up the method lookup in such a way that now let's say if the method is not there in the actual class, the class that has the included module, then you're going to go to the module now, and then if it's not there, I imagine you're going to go to the super class.
No, the other way. When you include, it goes to the class first when you include.
Yeah.
Yeah.
So it goes from the class and
Then to the copy of the module. And that's
yeah.
why, I was just thinking the book doesn't mention the word. I think if the book mentioned the word override, it would help with the mental model of this. I think like one way to think about it, he's come up with this use case where he wants to override the method name in the mathematician class by including a module. But you can't do that because it's going to look up in the class first. And then that's why he would use prepend. But I think by not he wants to override the behavior of the name method to prepend the word pro, like the prefix prof. And maybe if he had used the word override, it would help with just the mental model of the use case or whatever. I don't know.
Yeah, I think maybe I have to try out this coding error, because I get what you're saying. Like the method lookup is kind of changes when you use prepend and when you use include. Like where
Yeah,
the,
if
where
you
the, mm,
yeah, if you're in a class and you want to override a method that's in an included module, it's real easy. You just write the method. But if you want to do it the other way, where a class already has a method and you want to, from the outside or whatever, modify the behavior of that method by including a module, then that's when you would have to use prepend. And I think, at least for my brain, the word override really helps me make sense of it there because it gives me like a use case to attach to it instead of just thinking of orders of a linked list or whatever.
okay. I think it kind of makes sense. I'll try out the code, then I
You know
I
what's
think.
funny? After reading this, I somehow became more confused about prepend than I was. Like, it's weird. I like understood prepend, and when I read this chapter and I saw the modules getting copied, which makes sense, but I had never thought of. And then I saw the origin pointer and the two copies of the class. I suddenly, like, all of a sudden couldn't make sense of prepend anymore. But I always used to just think of it as like, if I prepend, it's like I'm including it in the singleton class. And if I include, it's like I'm including it in the class. But it clearly doesn't work that way. I just assumed it did because conceptually that makes sense to me. So I was shocked to read this, and it actually made it harder for me to think about Ruby from a mental model point of view than before.
Uh, yeah, I think Nelson, you can continue, because I'll have to just try out the code and I see. Yeah.
Sure. Yeah. Okay, so modifying a module after including it. So basically, this is an experiment to see what happens when we modify this module professor uh, uh, after we include it. I mean, so we have this code where we say we define a module professor with this lectures method, and we're going to print out all the methods, and we're going to sort, and we're going to find, okay, great, we have this lectures method there. That's fine. But what happens if later on down in the code, we also, so let's imagine that we have this code, and then after all of this code, we add this code. So we open up the professor module again, and we add primary classroom. Then we see, oh, wait, okay, primary classroom also gets included in that methods list. Which because we've seen that this is a copy of the professor module, I wasn't 100% sure it would work. I wasn't 100% sure if we were going to modify the original professor module or this copy of the professor module, but it looks like we operate on the copy. Okay, so then we're gonna do this other experiment where we have this employee module and this professor module where I'm sorry, the previous recording finished. That is why this folder pops up. Okay. The previous recording has to finish compiling or compressing or something. Encoding. Okay, so now what we're doing is we're opening up the employee module. And we're including this employee module in the professor module. And when we look at the list, we see, okay, well, no, we don't have that extra method. So what happened? We don't see hire date here. So here we're modifying the original professor module, not the copy of the professor module that we made. Okay.
And actually, I don't know if so I actually did this experiment and it no longer works this way. So it now works. Yeah, I was actually shocked by this as well because I was pretty sure it didn't actually work this way. So I tested it out and it doesn't work this way anymore. But I could share my screen to just show the code, or I could just tell you, you now do get if you did this experiment now, you do get that method. It does show up.
Okay. Well, good. I mean, it's sort of confusing that it works in one case and not the other.
Yeah.
Yeah.
There's definitely random little inheritance things that have gone from, wow, I can't believe that doesn't work, to just working over time. And I guess this must be one of them.
Yeah, the principle of least surprise, right? Like if you would just expect it to work, then
There's another thing I could mention, unless in case you guys aren't aware of this technique, but up above, like where he shows the list of methods, I always like to subtract object.methods. Do you guys do that? So I'll do like for ma.methods minus object.methods. And then it would only show first name, last name, lectures. It wouldn't have all the methods, just the ones that aren't in object. It's super useful.
Yes, I've done that before.
Okay.
But isn't there also instance? Is there only instance variables?
There's an instance methods thing, and you can pass true or false to it. I can't remember if that controls inheritance or whether it's private or not, but either way, I didn't think to try that for this case because I don't know what it would do or how to interpret it. I guess I could have at least tried, but yeah, here I didn't try that.
Yeah, subtracting all the methods that you inherit from object is really good because usually you're not interested in any of those.
Yeah.
Okay, so yeah, well, I guess we don't. This is basically talking about how all of this works, but as you've just described, it works differently now. So I feel like we can just skip this because it doesn't work this way anymore.
Right, yeah.
Okay, so we've been skipping the C code. It's hard to read the C code actually.
Yeah, you know what was weird is that I realized it didn't work this way anymore, and that kind of killed my motivation to read the C code, only because I knew it was no longer applicable, but I guess I could have read it anyway. But I did skip this chunk of C code.
I think we have to hurry up, so I'll just go, I'll skip to constant lookup. So it's basically saying here that a lot of the constant lookup works the same way where we trace through the inheritance hierarchy, but we also have this other little wrinkle here where it's going to use the lexical scope to try to look up constants. So it's worth looking at how constants work because we're going to get a view into how lexical scoping works in Ruby a little bit. Okay, so finding a constant in a superclass. This is basically the same idea as we encountered with the method lookup. So if we have some constant defined in a superclass and we try to print it out in this subclass, it is gonna go cycle through the inheritance chain and find that constant in the superclass and be able to print it out. Great. Okay, so what about what about namespaces or modules? So we're using this module as a namespace. So we have this constant, and we're going to try to print out that constant. Does it go through the inheritance hierarchy? And here it basically says no, it does not, because the superclass is object and not this namespace module, which is a little surprising to me. I mean, I guess that we haven't created a new instance of subclass, right? And so because we haven't created a new instance of subclass, we didn't we don't see namespace included yet in the class hierarchy. I think that's what's going on. I'm not 100% sure.
Well, one thing that helps me here is to just think of classes and modules as constants too, because like there's multiple constants here. There's namespace, some constant, and subclass. It's just really a naming convention that we use all caps for some constant. That kind of helps because if you put two different classes in the namespace module, you can, like you already know, you can intuitively access them, even though they don't inherit from one another, and you don't have to prefix it with namespace. So that kind of helps me just know that you can either do it through lexical scoping or through the class hierarchy. It is interesting that you can do it through either, though.
Well, so part of me was confused because I was expecting this thing that we saw with methods where, sorry. So we have a module, we make a copy of the module, the copy of the module gets shoved into the inheritance hierarchy here. So what was confusing to me was like, wait, is that not happening in this case? And maybe it's not happening because we're not using the include keyword. It's
Right.
just lexical scope. So because that include keyword would create that hierarchy, and once we've created that hierarchy, we'd be able to find like namespace would be a superclass of this subclass. But because that's not happening here, we're not using the include keyword, and we're not creating a new instance of this subclass. Like,
Yeah, it's still, I think it first does try to find it that way and fails, and then starts looking through the lexical scope. So I think it does two different lookups.
Okay,
So
yeah.
it tries through and I can't remember which one it does first, but I think it does something like the method lookup first. Doesn't find it because the parent class's subclass is object. So then an object doesn't have some constant. So it's like, gosh, I didn't find anything. I guess I'll start looking through the lexical linked list instead.
Yeah. So do you think I'm right, Miles, in that because we're not using the include keyword, it's not
Well, I think
actually.
it you could either use include or you could inherit from a different class that has the constant, but we're not doing either of those. So we're not using extend, include, or prepend to
Yeah,
accomplish it, but we are accomplishing it through the lexical scoping. So it I think it exhausts the inheritance hierarchy first.
yeah.
And I can't remember if it does that first or the lexical scope first, but I think it exhausts all the inheritance options first, and then falls back to looking through the lexical scoping.
Okay, good. Yeah, later on in this chapter, it's gonna specify uh which one it does first.
Yeah, I have a question.
Go
So
ahead.
my question is directed towards Miles because I'm referencing his project. Yeah, I'm referencing Fubara.
Mm.
So in this code, I understand that okay, in this the code Nelson has been referencing, you have a module that's called namespace. Yeah,
Uh,
but my question is, what is a namespace in like any other context in Ruby? Like, what is a namespace?
well, I do think of the module and the class here as both namespaces. So I think in Ruby, I guess you have a top level namespace, which I think of as just being inside the object class, but I don't know if that's an accurate way to think of it or not. So I think of module as a namespace, class as a namespace, and then maybe the top level is a third namespace. And I don't know if there's others, but those are the only three that I'm aware of. I don't know if I'm answering your question or not, though. But um,
Because you like in our conversations you tend to reference it, like the ones we've had over the P about the PRs we've worked
oh,
with. Yeah,
I
you keep
see.
on
So
referencing it.
yeah, in my project, I have a concept called a namespace, but it's unrelated to the Ruby namespacing. It's like
Oh,
a different thing. It's like its own
okay,
thing. Yeah, yeah.
okay. Mm.
Okay, so a namespace is basically like here, where we have this class name subclass. If I were to try to create a new just subclass, this is gonna fail. Why? It's because it doesn't exist in this namespace. It exists in, so we called it a very confusing thing called namespace. So the full name of this thing is namespace subclass.new, and now it's going to work. So basically, we do this when we have something like, so like integer exists, right? Like one, if we do one dot class, integer, it exists. But let's say that we have our own library that we want to use, and we don't want it to conflict with integer class. So we can namespace it, and we can say, okay, so it's going to be module Nelson's code, right? And then this is going to be class integer, right? So we can now in our code, we're going to say like Nelson's code integer.new, and that creates a new class, but we've namespaced it. So now the one class. So now integer exists on its own, and this other integer also exists, but it's in our own namespace that we've defined.
I've actually been using this, but I didn't know the reasoning behind it. Yeah. Okay, it makes sense.
Okay, so Yeah, okay, so we've talked about this. We're saying, okay, it didn't exist, like the object is the superclass, so we couldn't find some constant in the inheritance hierarchy, so we're gonna have to use the namespace to try to look for it. So it's we gotta look, we gotta define what lexical scope is, and it's basically a section of code within which with a syntactical structure of your program. So anytime you see an end, that's basically telling you that it's the end of some scope, some lexical scope. So a class is one lexical scope, and a method is another lexical scope. When you're iterating through an array of objects and you're doing dot each, that's another lexical scope. So basically, you have a hierarchy of these lexical scopes that you have to look through, right? And in your code, you're basically looking at all those end keywords and saying, okay, so first we start by the most indented end keyword. So in here we have end. So here's one lexical scope. We don't find it in there. And so now we have to look through this other lexical scope to see if it's in there. Okay, so basically it's going to keep a reference to it describes it as the parent or surrounding lexical scope. And this class pointer describes the current lexical scope. So we're going to start with the current lexical scope, and we're going to keep cycling up to the next parent lexical scope to try to find the constant. So this, I wasn't 100% sure what was trying to be said here in this figure. When you declare a new class, Ruby creates a new R class structure and defines a new constant set to the new class's name. So the dashes, do they mean, I was confused because in previous diagrams that we've seen that the dashes represent something that used to, this class used to point here, and now the solid line points here.
Yeah, that is confusing. I guess he's just changed the meaning um, of what a dashed line means, is my guess.
The other thing that I thought here was, okay, so these lines are coming from the class. So this class has an inheritance hierarchy that defines the current class and the superclass. But so the namespace would be the superclass if it was included, but it's not included. So maybe this is like the dashed lines represent the inheritance hierarchy if it existed.
I think it's just trying to say that do you remember me mentioning earlier that I think it helps to think of my class as a constant? So there's two constants here. There's some constant and my class. Those are the two different constants here. So I think he's just trying to show that these two constants belong to the namespace module. Like, so we have the outer wrapping module namespace that's not in gray, and then inside the gray area, he's showing that as two constants in the constants table in the namespace module. So the namespace module has two constants, and one of them is my class. And I don't know why the lines are dotted. I don't know what he's going for with that. But I don't think it has anything to do with inheritance, or certainly not class inheritance, I don't think.
Okay. All right.
So we have
Yeah, I
two, we
wasn't
have
I
two,
wasn't 100% sure.
yeah, I think we have two R class structures here. One of them is the namespace module, one of them is the my class module, and one of them has a constant pointing to the other. But yeah, I also find that confused. Oh, there he says what the dashed lines mean. It says dash arrows in this figure show what actions Ruby takes. Oh, okay. Well, I find that kind of confusing, to be honest. So
Yeah. So I'll just read it. Ruby creates a new R class structure for the new module or class as shown at the bottom. Then Ruby creates a new constant using the new module or class name and saves it inside the class corresponding to the parent lexical scope. Ruby sets the value of the new constant to be a reference or pointer to the new R class structure. Okay, so basically, in this lexical scope, we have this thing that points to the current class, and then this ND next, which points to the parent lexical scope, and then it has in this class pointer, it has the constants defined in there. Okay.
yeah, I suppose there's one last step actually, which is that the class has a name and the name gets set as well, which isn't very interesting. But I every once in a while you'll wind up in a situation where a class you're like on a breakpoint and the class doesn't have a name yet. So there's like a little tiny window where the class doesn't have a name. Um, so yeah. Anyway,
Um, Yeah, so I mean, basically, it's going to look in this, like we said before, it's going to look in this lexical scope. It's not going to find it. It's going to go to the parent lexical scope, and it's found here. So
yeah,
yeah, I mean, and in this diagram, it's going to look in this lexical scope. There are no constants here, so it's going to go to the parent lexical scope, and it's going to find some constant here and return that. Uh, yeah, that's basically saying what it did. This is the algorithm, so it sets the constant reference or the cref pointer to the current lexical scope. Look through the constant table for the cref's class. Did we find the constant? Yes, then we're done. If not, then we set the lexical scope to the parent lexical scope, and then we try again. Okay, so which constant will Ruby find first? So if it's a race between a class constant or a module constant, which one is it going to find first? It's going to be found in the parent lexical scope, so it's going to find
mhm.
the lexical scope first before the superclass.
Interesting. So I had it. I remembered it wrong. I remembered it backwards then.
Who knows? It could have changed. Oh no, no,
Oh, that's
actually,
true.
no. This one I did type into IRB, and it still works
Oh,
the
okay.
same way.
Got it. Got it.
Yeah. Uh, Unfortunately, things aren't quite so simple. So we have this thing called auto load, and basically we're auto load loads a file from some other place and puts the contents into the current scope, I guess. So we're gonna search through the current lexical scope. If it finds an auto load, it's gonna load all the code from the auto loaded file and check whether or not the constant is there. If not, it's gonna search through the superclass chain. For each of the superclasses, it's also gonna check for any auto-loaded code. And then at the end, it's gonna call constant missing if it doesn't find it. Yeah, and that's basically the end of the chapter. I don't know how much time we have left, but
We have roughly 8 minutes. I have something to present.
Oh, okay. I'm gonna stop
Yeah.
sharing then.
Okay. So I tried this thing out. I don't know if you guys can see my screen.
Yeah.
Yeah.
Yes. So this is the like what happens when you try to include a class. Yeah.
Oh, okay. So you get
Yeah.
an error.
So this
Yeah.
is the error you get. But now I've looked up like the explanation about the include method when you go to the Ruby documentation. And now that is what I'm going to project next, and then you guys, I don't know if we can brainstorm the reason. This is the C code, I think, that is behind the implementation of the include method.
Okay.
Yeah, I don't know if you guys can see it.
Check type. So there is a thing there that's checking a type is T module. I don't know.
Yeah,
I don't know what that means though.
I think, okay, according to ChatGPT, the error is raised at this point. The point where you have 4 and then inside the brackets you have I equals 0 and then I less than
Mhm.
argc, and then you have an
Yeah.
if statement that does rb raise if you have a type error. And I think you have cannot include refinement. I think in this case the module was the name of the module or the class was refinement.
So I guess that check type function or macro or whatever it is, it somehow can take that argument, figure out its type,
Yeah,
whatever that means in the Ruby interpreter, and then is able to compare it against a module type. That suggests that there's probably also a class type, but I don't know. I don't know if there's a T underscore class or not. Who knows? Or I guess we could check the code, but
yeah, but it's C code
So,
though.
so I think this is happening before it gets to Yarv, right? So, first we run it through a lexer, then we run it through a parser, and that parser creates an abstract syntax tree, right? And that abstract syntax tree has to represent uh, the uh, semantic meaning of the different things that it finds. And when you create a module, like when it sees the word module, it creates this thing of type module, T underscore module, for the abstract syntax tree. But uh, but I don't think it gets to the runtime.
I think it has to be able to get to the runtime though, because this could be dynamic. Like you could eval a string that's the name of the module and it would work. So I don't think it can tell at parse. It can't know at parse time if the thing being passed to include is a module or not. I just don't think there's a way for it to know. Because you could like create a method that returns a module and include the return value of that method, which would have to be runtime, not compile time. Could test that out. I mean, we could test that out in IRB, make a method that returns a module and then include it in a class. But my guess is that this is actually past Yarv. Like Yarv is calling out to this C code to implement the include method. Is my guess.
Yeah, so I'm not sure about the YAV because that's like now like a lot of detail for me to understand. But I tried out something else, and here I just try to I create a module in addition to the two classes I created first. So this module is called example, right?
Mhm.
Line 8 and line 9. And then after that, I check at the very bottom, I check example.class, and then it returns module, and then person.class is going to return class. So I think the low level implementation of the include method uses this to check, though I'm not
That might
sure.
be. So you're saying it might use the superclass pointer to figure out if the
Yeah.
thing is a module or not. That could be. I wonder if we could find the source code of that check type function and or macro, and maybe that might
Yeah.
answer it. I don't know. That could be. It seems like that'd be an inefficient way to do it, but it could totally be the way it does it.
Yeah. So that was my presentation.
That could be it. Yeah, I hadn't thought about that. Yeah, maybe it just looks through the inheritance chain to answer the question. I don't know.
Yeah. So I think that's it. We have like 3 minutes left, and I don't know, Nelson, if you have any concluding words.
No, I mean, I am like, it's still hard for me to read these chapters. Like it's still, I have to reread them in order to understand them. But I am getting something out of them. Like I do have ideas about why things might work, or how, I am connecting it to the Ruby code that I write. So I'm glad we're reading them and getting through them.
Yeah, it's definitely a cool read. It's a great read. I also get confused and then have to reread and kind of interpret sometimes what the author is trying to convey. So yeah.
And often it's not until these sessions that where, like I'll ask something and you'll give me an answer that clarifies, like, oh, no, that's not how it's working, or that's not what it's describing. Here's the way it works, and that really helps understand the chapters. In the previous
Yeah.
book that we read, like it was so simple. I'm not so simple, but like it was straightforward. I didn't come out of the chapters confused, and I feel like in this book I am sometimes coming out, even when I'm reading it twice. It's just I'm still a little confused sometimes.
Yeah, like I had mentioned when we were chatting, I actually am kind of shocked sometimes. Like when I saw this diagram where it was like making two different copies of the two different modules, which makes sense. I just never thought of it that way. And then the thing with the origin pointer, I was like, what? Oh my gosh. Like, so those are things where I don't want to connect it to my Ruby code. Like, I do not want to think of it that way. Like, I do not want to think of mathematician as technically existing twice in the hierarchy because it's just confusing to me. I only want to think of it being there once. But yeah.
Yeah, definitely
Yep.
override. Thinking of it as an override is much simpler.
Yeah, there's a thing where it's an interesting thing because we're learning the details of one specific implementation. And so it's an interesting thing because there's like the way you think about Ruby when you're writing the code, and then there's the details of the underlying implementation. And it's just kind of fascinating that they're not the same thing exactly. Um, so yeah, it's interesting. Like I've never actually read a book like this before. So
Oh, wait,
it's a pretty cool experience.
who's presenting next time?
It's Miles.
Oh, it's me. Okay,
Yeah.
I'll do that.
Okay.
Okay. So have a great week, guys.
Okay.